I violated an important rule of thumb that may force me to remake this bearing. It's 520.526 in diameter, but that's not the important thing. The important thing is there's no hole here to stick it into. Now I can drill a hole and then bore it to 0.526, but the boring operation isn't nearly as accurate as turning. The rule of thumb is turn to fit the bore rather than bore to fit the turn. So I've got to figure this out. Do I want to try to bore a hole that'll fit this bearing, or do I want to rebuild this bearing after I bore that hole? It's not a, it's not a huge problem, but it's an hour or so work. Plus, I'm upset that my order of operations, I got ahead of myself. I should have created this hole and then turned this bearing to fit. I need to locate the hole for the main shaft in the pedestal of the engine, and so I'm going to use my new granite surface plate. Life sure is a lot easier now that I have one. Before I had one, I couldn't figure out what I was really going to use it for. But after I got it, I use it almost every time I do some job. So I've already zeroed the device out, and I want to locate the hole 2 inches above that the bottom of the base, above the base anyway. So there we go, 2.0 exactly. I'll just scribe a line, and then we'll do the same thing here. I want a line crossing this one at a 1/2 inch from here. So I'll scribe that, but I don't need to torture you with watching me fiddle around doing it. I've got to create this 1/2 inch plus diameter hole at this location that I've at this cross mark. I'm not sure you can see it, but it's there. And drilling a hole sounds easy, and it is. But I could simply stick it in there in the vise, clamp the vise down and drill it. But I'm just a little worried about drilling over this space here. That's unsupported in there, and I looked through all my blocks and parallels and everything, and I couldn't find anything that was just right. So what I came up with is a couple 3/8 inch dowel pins of the right length. So stick them in on the bottom of the vise. They're standing up down there like that, and I'm not worried about them. I'm not worried about them being straight or wobbling around holding it, because when I clamp this thing down on the sides, it will straighten out. And now, when I drill, I won't be drilling over an unsupported workpiece. That's the point. I don't want to drill over an unsupported workpiece. Okay, here's the plan. To drill the hole in the main shaft, in the pedestal for the main shaft. I'm going to locate it with using this pointy center thing. Then I'll center drill it, step drill it a 1/4 inch, and then drill it 1/2 inch, and then we'll see how the bearing fits. It won't fit because even though drill bits drill oversize, I don't think it'll drill out to 0.512. We'll have to bore it from there. And if I miss the bore, when I'm boring it, if I miss it and bore it too large, then I'll simply have to turn another main bearing. Notice also that this is the first time in this project that I've had enough vertical space to use the drill chuck. So I've got the whole position indicated, and now it's simply a matter of making sure I'm lined up. Okay, I think I've got the camera positioned where you can see and it's out of my way, so we're going to center drill the main bearing hole. My new spindle runs nice and smooth since I had it replaced by Grizzly, and adjusted the preload on it. I've only got when I adjusted the preload, I got it down to 5/10 thousandths, and after a few hours of operation, I'll check her again. That was the 1/4 inch step bit on the way to 1/2 inch. And I'll have to lower the table. Fortunately, I can do that. But can I do it without hitting the camera? That's the question. The tripod, I mean. Tapped it. I don't know if you could see that or not. Caught it. It's always good. I'll probably cut this part out. I'm going to use this little 1-inch boring head. I think it's made in India. I can't find any markings on it, but I can vaguely remember buying it years ago, and I think it said India. Could be wrong. No markings. It's probably Chinese. But I had some pretty good luck with it in the past, so we'll try it again. I need a good some good heads. I've got 3. I've got this 1-inch and a 2-inch and a 3-inch. They're okay. I've been able to do what I want to do with them. All right, I'm going to use a telescoping gauge snap. Some people call it a snap gauge. I don't know which one is preferred, but Lufkin calls this set telescoping gauge, so that's what I'm going to call it. Stick it in the hole, compress it to fit, put it off at an angle, tighten it up so it doesn't come out, doesn't uncompress. You got the size of the hole right there. Carefully mic it. And I've got 501 and a half. Let me do this again. Let her loose. Stick it in the hole. Big end down. Big end on the slope there. Lock it. See what we get. .501. Can't see. There, 501 and half. 5015.5015. So I'm gonna bore that baby out to something I hope will allow me to have I'd like a slight press fit, a very slight press fit instead of a slip fit on that main bearing, if I can get it. I'm going to use, oops, let's go, there it is. I'm going to use this little bar. It's a borite, I'm not going to use this one. It's too small. I'm going to use this bar. It's a borite A5L-2, a cemented carbide tip. All right, there's the boring bar set up. I'm going to try to bore this at 235 SFM, which means 1800 RPM at that diameter, but I don't detect, let's see here what it feels like. It feels pretty good. There's no vibration in the mill. Nothing's flying apart on that boring head. So there's our first cut to locate what we're doing. Let's see if I've got enough room to get a telescoping gauge in there. Around this boring bar and boring head. Yeah, it looks like I do. So we were at 5015.5015, and now that very light pass, we're at a grand total of 5065. So, took 5 thousandths on the way to 512. Took a lot more than I expected. Of course, it's not quite. I'm going for a very light press fit, so trying to fit it in there at this time is silly anyway. All right, so I'm going to I'm going to sneak up on it. I'm going to try to take 3 or 4 thousandths off. You know, I don't know if this head is direct reading or not. I set it to take 3 thousandths off. Is that going to take 3 thousandths off the radius or the diameter? This could be important. If it takes it off the diameter, then I'm right at the size and I'm not sneaking up on it. And that's not what I want to do. So I'm going to back her back down. All right, here we are at where we started. And this ought to be a light spring cut. More or less. I mean, it ought to be about that much. And it sounded that way too. So maybe we took a couple thousandths, which would be fine, because I really want to sneak up on this thing. Yeah. I really like to use these telescoping gauges, but in tight circumstances they can be a little tough. Not real happy with that finish. I probably screwed it up on the way up, so on the final pass I will not come up with it turning. I'll go down, I'll cut down, and then shut the machine off and move the bar away from the work. All right, we're at 506. 5061. I don't know what I said it was last time. So basically we didn't take any. So now I'm going to take 2 thousandths and measure it, and then I'm going to write 5061 down so I can remember it. And then we'll take 2 thousandths and on the dial, and then measure the hole and see if it's if we really took 2 thousandths off or if we actually took 4 thousandths off, and that way we'll know if it's direct reading or not. Alright, I've set it to take 2 thousandths on the dial, and the question is, does it take 2 thousandths on the radius or the diameter? We'll take this 2 thousandths and then measure the hole and find out. I wanted to come up slow to try to see how good a finish I could get. I'm thinking that this bar might have the wrong relief behind the cutter. I just don't know. What I ought to do is switch to carbide insert bars. Anyway, it's going to be good. The finish is going to be good enough for this bearing fit. That's all that counts. But you know, you always want to make it look like glass. Alright, let's see what we're at. We were at 5061 and we took 2 thousandths off according to the dial. So now we're at 5146. Let me mic this baby again. Same thing, so let me measure it again. Five 13, way up there, let's see, 513 9, 5139. Well, that's bigger than I wanted, of course. This bearing is liable to slide in there and fall out. We'll see. All right, the hole is 513.9 and the bearing is 512, and the bearing's got a slight chamfer on it, so it ought to kind of start down in that hole, but I can't get it to from this position anyway. But I'm confident enough in my snap gauge, my telescoping gauge measurement, that I'm going to leave that hole that size, and if I absolutely must, I'll build another bearing to fit that hole like I should have done the first time.